All right, guys, what questions do you have? Well, that's exciting. All right, Sophia. Why won't it turn off, honey? Okay, good. All right, I did grade page 436, and I guess there was some discrepancy on what I assigned in class and what I put on School Fusion, so I apologize for that. But I was looking for the one that I assigned last Thursday, because if you remember with all the snow days, we had class Wednesday, Thursday, Friday last week, or something like that. Thursday, Friday, today, I'm not even sure. But I assigned something on Thursday, and I said rather than check it on Friday because I wasn't going to be here, I would check it today. And so it was that page 436, 17 through 26 all. Is that right? I graded number 24, and if you want to look at that first, the answer should have been either 37 over 5 or 7.4. Either one I accepted. Are there any questions about any of those? Any sure? How about on the 7-1 worksheet? Anything that we're really not sure of? I know you had to watch a video. I should say? Yeah, no, come to you. Go ahead. 12 through 15. Okay, so let me just start with 1, and maybe that'll help you, okay? So if you're looking at question number 12, it has this picture here, which is fine, but really what's important is the ratio that they give us. They tell us that A over B equals 2 over 3, and then they say to complete the rest of it. So I'm just going to do 1 with you, okay? Is there one? Let's do 15, okay? So in question 15, it says B over what is equal to 3 over what? Well, B over what is 3 over what? So we just use this proportion to answer those questions, okay? So in other words, look where B and 3 are in the given proportion, and how can I figure out where 2 and A go in the other? So it's B over A and 3 over 2, so B over A and 3 over 2. So you're just using the given proportion to answer the question. That's all. You're just rearranging it. That's it. Oh, just if I don't, it's just use the given proportion. You don't have to write words. That was your question. Okay, yeah. Yeah, I'm sorry. Yeah, the justify is just based on the given information. How do I rearrange my proportion to be equivalent? Because they are equivalent proportions. All right, Demetra, you had another question, honey. Number 7, okay? Now, that was one of the examples I did in the video that you guys had to watch, right, with the extended ratio. So if we look at that particular question here, it says the measures of the angles in a triangle are in an extended ratio of 6 to 1 to 5. Okay? Now, if you remember the video, I said that the ratio will say 6 to 1 to 5, and it does say, oh, no, I drew it wrong. Why? Because it's angles, and what did I mark? Sides, right? So we have to be real careful. So we're talking about the angles. So I'm just going to write them into the 6 to 1 to 5. Obviously, my picture is not drawn to scale. I'm not so concerned about that right now. So that's my ratio one. And here is my similar one that's going to be the actual triangle. And it says, what's the measure of the largest angle? Okay, well, what did I do in the video over here? What did I do? I called, if this is the ratio, all of the real angles are multiplied by a scale factor, or a factor of x, I think I called it in the video, right? And so I said, okay, this would be the same thing as 6x, 1x, and 5x. I just don't know what that x is. Some number, right? And if I know something about angles, what do all the angles add up to be? So what is the equation I'm looking for? 6x plus 5x plus 1x equals, and then you solve for x. Once I figure out x, how do I find the largest angle? I plug it back into, wouldn't that be the largest one? And that's your answer, once you figure out what x is. Angles always add up to 180. If it talked about the sides, we would have to be given the perimeter, because all the sides add up to whatever the perimeter is. Okay? All right, any other questions? Yes, ma'am. Number 6, okay? That's the same type of picture, except what I just said was that they all add up to the perimeter. So you're going to draw a small rectangle, and a big rectangle, right? And you're going to add them up. So if the ratio is 2 to 5, you're going to have, if it's 2 to 5, isn't this 2 and this 5 also? Okay, and if it's that's the ratio, and I'm going to multiply them all by an x. I'm not sure what that x is. And you add them all up to be the perimeter, right? Jared? 16. Okay, on 16, it says to write the ratio in simplest form. So you're going to literally count to find the AC. What is the length of AC? It's 6. What's the length of AD? 8. And then you just reduce the ratio 6 over 8. That's it. Okay? All right. I'm going to go ahead and take these, if you would. Go ahead and turn them in just into this, to the big chair for me, if you would. And then we're going to go ahead and take your notes out, and we're going to talk about similar polygons. So we should have a new section in our binder. We should have another binder check probably on Thursday. I didn't have time to make it up for today. And that section should be called Similar Polygons. As of right now, the only thing you have in it is the homework that you did, that we just checked, and I believe you copied down an example into your notes as well, did you not? So those are the only things in this section so far. But go ahead, if you would. We are going to have a quiz next class. It will go on quarter 3. It's going to be on these types of problems here. Okay? So it will be on solving proportions. It will be on the extended ratio thing. Okay? It'll just be very similar to this, reducing the ratios, etc. So, you know, that's section 7-1 in your textbook. So if I were going to be studying for this quiz, I would look in my book under 7-1, maybe try some of the odd problems since they're in the back of the answers or in the back of the book, and that'd be a good way to study for that quiz. Okay? All right, so today what we're going to talk about is similar polygons, and so if you would go ahead and put today's date, which is the 20th, and we're going to title our notes for today just Similar Polygons. Okay? Now, we first need to talk about what does similar mean, okay? Similar versus congruent. Now, if you know, we just finished a whole test, a whole section on congruent. So let's kind of take a step back for a minute. What was congruent? If two figures were congruent, what was true about them? Maybe we should do this. Let's draw a little diagram. I don't know if they should overlap or not. And let's figure out what we know about similar, what we know about congruent. Are there any things that they have in common? Are there any things that's only true about similar or only true about congruent? Okay? You guys have seen this before? It's kind of a map. Compare and contrast. What do you think? Similar. We'll start with congruent. What is congruent? What does it mean to be congruent? Say what? Equal, okay. What's equal about them? The sides are all equal. I agree. Here's what's true about similar. Their sides are not necessarily all the same length, okay? But the sides are. So all corresponding sides are congruent or the same length. Only congruent triangles. Okay? Always true about congruent triangles. Some similar triangles have congruent sides, but not all. Okay? Give me something else you know about congruent triangles. Well, we know something about the sides. What's true about their angles? And congruent triangles. Are their angles the same measure? You should know this definitively. Yes. All the angles and all the sides. Would you agree? So here's what's true, though. Similar triangles also have congruent angles. So all corresponding angles are congruent, have the same measure. We'll use that way. So the angles are congruent. Angles are the same measure for both congruent and similar. Anything else you can tell me about congruent? Can a triangle be congruent to a rectangle? No. So what has to be true about their shapes? They're the same shape. And guess what? Similar too. They are the same shape. Let's draw these as separate little inside bubbles. Same shape. But with congruent triangles, they have to be the same size. Okay, you can have a small triangle and a small triangle, but you can't have a small and a big. Would you agree with that? So these are going to be, if they're congruent, they have to be the same size. Not necessarily true for similar. What's true about similar polygons is that they have what's called a scale factor. Okay, one is bigger than the other by a certain percentage. You know, like if you were going to make something larger, and like you're doing a word, you're drawing a picture in Word and you want to blow it up, you can like scale it by a certain amount, right? So it's the same kind of thing. Okay, so these have scale factors. Okay. What if the scale factor is 1? If I take my hand, for example, and I want to make a similar hand with a scale factor of 1, how much bigger is it going to be? Not at all. It's going to actually be congruent. Would you agree? So congruent have a scale factor of 1. Similars can have a scale factor of 1, but they can have other scale factors, 2, 1/2, 3, 0.27, 216, any number you want, any positive number. Why would a negative number not make any sense? In geometry, often negative numbers don't make sense. If I multiply by a negative number, I'm measuring length. Can length be negative? We're talking about direction, vectors, yes, but for our purposes, we're going to say no. Okay? Here's a question I would say that you could possibly see on a future test or quizzes. Okay? All similar polygons are blank congruent polygons. So write these two sentences for me. All congruent polygons are blank similar polygons. I want us to fill in those blanks with words sometimes, always, or never. I want you to think about it for a minute before we get the answer. So write them down, and in the blanks, you're going to fill in the words sometimes, always, or never. So based on what we just kind of assimilated in terms of our knowledge, the difference between similar and congruent, what do you think? All similar polygons are always congruent, sometimes congruent, or never congruent? What do you think? Taylor, what do you think? Sometimes. And when is that sometimes? When the scale factor is what? 1. So the only time that a similar polygon is a congruent polygon is when the scale factor is 1. So we will put sometimes in that answer. Okay? Good. How about the second one? All congruent polygons are sometimes, always, or never similar polygons. What do you think, Sophia? Nope, I disagree. What do you think, Jesse? It is always. Okay? Congruent polygons are always similar. Okay? Could we draw a Venn diagram to represent, now this is not a Venn diagram at the top, this is just kind of like we call this a compare and contrast map, bubble map, you might have called it that before. Not a Venn diagram, but if we were going to use our geometry knowledge and draw the Venn diagram that shows the relationship between similar and congruent, how would the circles look? Would they overlap? Would they be separate? Or what would one be inside the other? One would be inside the other. I agree. Which one is which? Congruent is on the inside. Very good. All congruent polygons are similar. Would you agree with that? But not all similar are congruent. I could have a scale factor of 3, have one 3 times as big as the other. That would be out here, wouldn't it? Okay, so it's possible. So that would be the Venn diagram that shows it. Good. Very good. All right, so let's take this a little bit further and let's stick with, we already know what congruent means. We know that they're exact same size, exact same shape, all the sides and angles are congruent, the corresponding ones. When we have similar shapes, I have a different statement that I write. And I've got it written up here in the corner here. You notice the symbol is used, it's a little bit different. Notice the symbol is just a little tilde, okay? It's just one, that's what similar means. If it was congruent, that would be on top of a what? An equal sign, right? So there's different symbols that mean different things. So this is what we call a similar statement, similar to a congruent statement, just a different symbol in the middle. If they're similar, that means that one could be bigger than the other if the scale factor is not 1. And the way I've drawn these two figures here, one is definitely bigger than the other. What does the similar statement mean? RSTU is similar to LMNO. Do you think the letters in the order that they're in matter? Did they matter before? With congruent triangles, didn't they matter? It matters here too, okay? So what corresponds to each other, it matters. Now, I'm asking the first question, and this is an important one, because the way that the state of Virginia talks about scale factor is completely, in my mind, backwards, okay? So we're going to talk about it. Scale factor of RSTVU, I'm sorry, RSTV, that should be a U, right? U. Okay, so RSTU to LMNO. It says here the short side is 9. How can I figure out what side is 9? Wouldn't it correspond to the short side on the other figure? So what's the short side over there? RS. So RS corresponds to LM. So I know LM is 9. You okay so far? All right. So how do I figure out the scale factor? So in the state of Virginia, it says the scale factor, if it's telling you the order of RSTU to LMNO means we're going to, this goes on top and this goes on bottom. So it's going to be 6 to 9. Does that reduce? What does it reduce to? 2/3. So that would be the scale factor, okay? It's telling you the order. Let me tell you why this makes me uncomfortable. 2/3 in my mind, if I multiply by 2/3, wouldn't I get a smaller figure? And don't I go from here to here and I get bigger? See why that makes me uncomfortable? But I'm telling you what the state of Virginia is telling me to tell you. Okay? I'm not saying I agree with it, but I'm saying that's the law. Whatever, okay? Scale factor in my mind means if I multiply by a number, I'm either going to get bigger or smaller. And to me, 2/3 means smaller. It's 2/3 as big. All they're saying here is that the first one is 2/3 as big as the second one, okay? So it's just the order of which they're talking. It makes me uncomfortable. I'll get over it, okay? But this just means the first one is 2/3 as big as the second one. Fair enough? All right. Find the 2 longest sides of LMNO. How would I do that? I would have to use the what to answer that question? The scale factor. I have to use the 2/3. So we're going to write a proportion to answer that question. So the two longest sides. Would you agree that 14 RU is one of the longest sides? So I would say that 2/3 is. Now remember, it went from RSTU to LMNO, whatever. Small to big. Would you agree? It went from small to big. Fine. So on the small figure, 14, and then what would I put here if I'm trying to find it? X. So you should be writing this down, right? This is part of the notes. Okay? And so this would be the proportion that I use to find the largest side on the other figure. So how did we solve the proportions in our homework? Cross multiply. 14 times 3 equals 2 times x. Or 2 times what is 14? 3 times the same number. Either way. So I'm going to pause the recording for a second. I want you to go ahead and solve this proportion, and then I want you to write a second proportion to find the second largest side as well. Okay? So when you solve letter B here, we're finding the length of LO. I agree. It's the longest side in the bigger figure. And when I solve for x, what did I get? What's the length of LO? 21. Yeah. No one wants to get up this morning? Tuesday after a holiday? I get it. All right. So 21. Good. All right. I need to find the other longer side. So what is the next largest side, the next longest side that I need to find? Use the letters. Which one?
No.
All right, TU is 12, but what is it on the bigger figure? No. NO. I didn't get what you were saying at first. I'm a little slow. It's okay. No. Yes. NO. I agree. So we want to write a proportion, okay? I know that a lot of us can do this in our head. I get that, okay? I know that you're smart. You wouldn't be in this class if you weren't. But what do you think I'm going to require you to do? Show the proportion, okay? So, sorry. I know. Manuel's like, yes, Miss Mackert, I can do it in my head. I get it. I know, but what's the proportion going to be to find? We're going to start with the same scale factor, right? 2 over 3 equals 12 over x. Let's call it a different, let's actually use NO, okay, since that's what we're trying to find. So let's just call it NO. And when I cross multiply or when I solve, or I know 2 times 6 is 12, 3 times 6 is what? 3 times 6 is what?
Oh, 3 times 6.
18. So isn't this 18? Right? 2 times 6 is 12. 3 times 6 is 18. That's one way to solve the proportion. If it's easy, and sometimes that number doesn't come up like that very quickly, Sophia, right? So cross multiplying would give you, and that happened a lot, I think, in the homework. We had decimal answers, right? And so if it's not a decimal answer, you can kind of do it quickly like that. But this part will be required. Okay, so show me that we call that a proportion. Show me the proportion. And what did I use to get to it? I used the scale factor, right? And then I used of the original, and then I used it to here. All right, so last question, or second to last question. C, the perimeter of LMNO. Well, I'm close. I still have to find what to find the perimeter. MN, okay. And what did I get there? You got 15? How'd you get that, Jared? I agree with you. You did it in your head. 15 is 2/3 of, no, 10 is 2/3 of 15. Yeah, the other way. I know, it's backwards. It drives me crazy too. But yeah, I agree, 15. All right, so to find the perimeter, what am I going to do? Add them all up. So what is 9 plus 21? 30. 45 and 18 is 63. Okay, so the perimeter is 63. What's the ratio of the perimeters? Did I count it wrong? Double check my math. All right, okay. So what's the ratio of the smaller one? The perimeter, if I add all these up, 26 and 16 is 32. And the perimeter of the big one, we said was 63. So the ratio would be 32 to 63. Did I add wrong? Whoa, 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 whoa. This is 42. I apologize. Whoop. Thank you. I wrote it wrong. 42. All right, so the ratio of the perimeters is 42 to 63. Guess what? Does that reduce? It does. What does it reduce to? 2/3. You think that's a coinkydink? The perimeters will always have the ratio of the sides. It'll have the exact same ratio of the sides. Okay? That does not happen with area, and it does not happen with volume. And we're going to look at that on Thursday. Okay? But for today, we know the perimeters have the same scale factor as the sides do. Awesome. All right. Oh, I was going to do the thing we're going to do. So I'm going to pause real quick. I have some problems for you guys to work on, okay, that deal with these similar ratios and whether or not they are similar. By the way, I told you in this problem that they were similar, didn't I? Didn't I give this to you in the beginning? What if I didn't know that? How would I check to see if something was similar? What would I do? You're on the right track. Now, the same size, but if all the sides had the same what? Scale factor, the same proportion. So I would check. And how would I check? So let me show you real quick what I mean in this particular example. If I wanted to check to see if they were all the same, suppose I didn't know this, but I knew all the lengths of the sides, I would say smallest to smallest is 6 to 9, the same as, I'm going to write an extended proportion here. 6 is to 9 as, 10 is to 15 as, 12 is to 18 as, 14 is to 21. And I would check all of those. Are they all the same thing? Do they all reduce to the same number? They should all reduce to what? 2/3. And do they? Let's check. This one does. Divide by 5, this one does. Divide by 6, this one does. Divide by 7, this one does. So since the extended proportion does reduce to the same number, which happens to be the scale factor, I know that they are similar. So that's one thing you're going to have to do to check. Okay? All right, when you are finished with that assignment, please make sure you turn it into the top tray on my desk. I do have a separate homework assignment from the textbook for you. You know you have a quiz on section 7-1 next class. You also need to do in the textbook the following problems, okay? All right, there you go. That's your homework assignment.